now we can also look at cube roots, simplifying cube roots. And so to do that we need to know our perfect cubes. Alright, perfect cubes are numbers like 1, 8, so that's 1 cubed, 2 cubed, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, and I don't think you're going to have to go much more than that, but you could. Okay, 6 cubed, 7 cubed, and so forth. We'll stop it there. Now, if you wanted to simplify a cube root, something like the cube root of 54, well, you look at this list and say, what numbers are factors of 54? The answer is 27. 27 times 2 gives you 54. And so then you take the cube root of each of those, the 27, and the cube root of 2. Cube root of 27 is 3. And the cube root of 2 doesn't simplify. And so that would be our final simplified form. 3 times the cube root of 2. Okay. So cube roots work in a similar way. You just have to find perfect cubes that are factors rather than perfect squares. Okay. Now, we're also going to look at simplifying variables or variable expressions. So let's take a look back at these square roots for a moment. If I wanted to do a square root of x to a power, let's say the power is 6. Now we did this a little bit in the last section, 7.2, when we dealt with rational exponents. This is the same as x to the 6th raised to the 1/2 power. And then you multiply 6 times a half and you get x to the 3rd. Okay? And now instead of writing it out, converting it from a root to a fractional power or rational power, you might as well just split that 6 in half, right? So the square root of x to the 6th, you use the square root to cut the 6 in half, you get x to the 3rd. And that works for any even power very nicely, right? The square root of a to the 10th is simply a to the 5th. You just cut that power in half. The square root of, let's go with, what do I want to go with? Maybe 20x to the 12th. Well, this one I'll run vertically. You're going to take the square root and split it up. I'm sorry, you're going to take the 20 and split it up into 4 and 5, because 4 is a perfect square factor. And you're going to also have that x to the 12th in there. Then when you do the square root of each of these, they simplify differently. So the square root of 4 we know is 2. The square root of 5 actually doesn't simplify. And the square root of x to the 12th we know is x to the 6th. We cut the power in half. And then when we write our final answer, it's nice to kind of keep that variable, keep the radical at the end, I should say. So we're going to use 2x to the 6th times the root of 5. I think the reason we put the roots at the end is because if you're not real careful, it can be misleading where this root ends, and sometimes it'll look like the x to the 6th is underneath it. So we like to keep the roots at the end so that things that come after it don't look like they're inside of it. Okay? So anyway, that's how we deal with even powers. We just cut them in half. With cube roots, the powers aren't going to be even that you cut down, they're going to be multiples of 3. Right? So if you had a cube root of x to the 15th, well, the cube root is really a 1/3 power. So this is like x to the 15th raised to the 1/3 power, which ends up being x to the 5th. And so to jump from the 15 to the 5, you just cut it by thirds, right? Take 1/3 of that number. Okay. Now, where it gets a little bit tricky